Hello, myself Dr. B.J.D. Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss regarding interprocessor arbitration. At the end of this video, the student will gain knowledge regarding what is interprocessor arbitration, what are the interconnection structures, and how the arbitration can be take place between multiple processes and what are the types. This topic learning outcome will match to the course learning outcome of summarize the concept of pipelining and interprocess communication for advanced processor design. The topics that are covered in this video are introduction, interconnection structures, interprocessor arbitration, and the types of arbitration. Multiprocessor systems are nowadays quite common. So these multiprocessor systems can support advanced computing capabilities that are required for the recent trends of the computer science and engineering. So a multiprocessor system is a single computer that can has multiple processors. So these processors can combine, control and coordinate in order to perform the task simultaneously. So it is possible that the processors in the multiprocessor system can communicate, cooperate at various levels of solving the problem. The communication between these processes can be generally takes place with the message passing technique, or the technique of shared memory can be used. What are the characteristics of these multiprocessor systems? Here, a multiprocessor system, the main characteristic is interconnection of two or more CPUs with memory and input-output equipment. Generally, the functional units of the computer majorly three. One is the input unit, second functional unit is the CPU, and the output unit. In a multiprocessor system, more than one CPU can be employed, which can share the common memory and input-output functional units. Here, the processor means not only the central processor unit. If at all, the system can be employed with input-output processors. So, IOP can also be considered as the processor. So, the IOP can be the major interface between the computer and the input-output devices. So, all peripheral devices can be connected with these IOP for coordinating. So scheduling can be done with the help of IOP. So the processor in the multiprocessor system can be the CPU or it may be the IOP. So multiprocessors can be having the classification and can come under the Flynn's classification of MIMD. So that means multiple instruction stream, multiple data stream category computer systems can be considered as multiprocessor systems. So, in multiprocessor system, from the characteristic, it is required that more than one processor can be employed in the system, and it can be the CPU or the IOP and can support MIMD architecture. So, how these processors can be connected, okay, that can be referred with the interconnection structure. The interconnection between the components of multiprocessor system can have different physical configurations. So how the system bus communication path can be connected, the processor with memory can be generally the major design issue in the multiprocessor systems. So number of transfer paths that are available between the processor and memory in a shared memory system. So among the processing elements, whether they are loosely coupled or they are tightly coupled is the major design issue. So how the transfer path between processor and memory can be defined is by means of interconnection structure. So here variety of interconnection structures are available. They are time shared common bus, multi-port memory, crossbar switch, multi-stage switching network, hypercube system. So these are the varieties of interconnection structures. The first one is time shared common bus. The architecture of time shared common bus can be share a common system bus between multiple processor and the memory. Here in this architecture, more than one CPU can be employed and a common bus can be shared between the CPU and the memory. So, which CPU can establish communication path with the memory? That is defined by the interprocessor arbitration mechanism. The next one is multi-port memory structure. So here in the multi-port memory structure, each port can be served as the CPU. And here the multi-port module, memory module control logic can be used to define the arbitration mechanism. And to resolve the conflict of arbitration, so here priority can be defined for the each CPU. How this multi-port interconnection structure is like this. So here more than one CPU and more than memory modules can be available. And the interconnection of the CPU and memory module can be done as the arbitration mechanism and can define the communication pathway between the CPU and the memory. So each port can be served as the CPU. And to define the arbitration, to avoid the arbitration conflicts, here for each CPU the priority can be defined. Depending upon the priorities, the CPU can establish a communication pathway for the memory module. Next interconnection structure is crossbar switch. So in this, each switch point has the control logic to set a transfer path between a processor and a memory. So transfer logic can, a switch can be employed in the communication pathway, the intersection of CPU and the memory module. This switch can be contain the control logic for the processor arbitration. So it also resolves the multiple requests for access to the same memory on the predetermined priority basis. So here also the priority of establishing communication pathway can be defined. So through this organization support simultaneous transfers from all memory modules because there is a separate path associated with each module. So the hardware required to implement this control logic can be a complex one. So this is the architecture of the crossbar switch. So here the CPUs and the memory modules, the intersection of CPU and memory module path, there is a switch, crossbar switch. This crossbar switch can be used to define the control transfer logic, and also it can define the priorities for the CPU for establishing the communication path between the processor and the memory. Next type of interconnection structure is the multi-stage switching network. So here the basic element is the multi-stage network. So this network can have two input and two output interchange switch. The inputs can be labeled as A and B. The output can be labeled as 0 and 1. So here the control logic can be defined within the switch. So the control signals start interconnection between the input and output terminal. So this is the architecture of multi-stage switching network. So here if the input, this is the multi-stage switch which is having two inputs. Those can be labeled as A and B, and the two outputs, those are labeled as 0 and 1. If A is connected to 0, this is the connection, and A is connected to 1, the input A can be connected to the output label 1, and B is connected to 0, B is connected to 1. In this way, the control logic can be established. And this is the binary tree with 2 by 2 switch, how multi-stage network can be constructed. So two processors P1, P2, and these are labeled as the input for the multi-stage switch, and 0 and 1 are the output. Depending upon the connections, so here the 8 combination and 8 arbitration binary code can be generated. And next interconnection structure is hypercube. The hypercube is a binary n-cube multiprocessor. For example, if it all n processor, two n processors can be, interconnections can be established. So if you take, this is the one processor, one cube, and if it are two processors are involved, this is the square type cube, and which is having the binary combinations of 0, 0, 0, 1, 1, 0, 1, 1. If it are 3 hypercube structure, it is a cubic structure with the 8 permutations. So the multiprocessor system, more than one CPU can be employed. And how these CPUs can be connected with the memory to share the common resources and data. So that is defined with the help of interconnection structure. So here variety of interconnection structures. What are the features of those interconnection structures we discussed. But how the common single path can be established between the processor and memory is the interprocessor arbitration. So the processor and main memory I/O devices can be interconnected by means of a common bus. So only one of CPU or IOP or memory can be granted to use the common bus at a time. Okay. So this arbitration mechanism is needed to handle multiple requests to the shared resources to resolve multiple contention. So here the major motto of arbitration is to resolve the conflicts of resource sharing or the bus sharing, and the control logic, the arbitration logic can define that the common pathway that can be shared at a particular point of time. So multiple devices may need to use the bus at the same time, so that they have there is a way to arbitrate multiple requests. So arbitration allows more than one module to control the bus one particular time. So these multiple requests can be handled with the arbitration mechanism. The arbitration mechanism can allow only one module to share the common bus at a time. The process of determining which competing processor master will allowed access to the bus is defined by interprocessor arbitration. So which processor can be act as master and can gain the common bus at that particular time can be defined by the interprocessor arbitration. So what are the types of buses? So here we are having in the multiprocessor system the system bus, the synchronous bus, the asynchronous bus. So what is system bus? A bus that is connected the major components such as CPU, IOP and memory is the system bus. So which is having a bus consists of 100 signal lines but can be divided into 3 functional groups. That is data bus, address bus and the control lines or control bus. The data bus carries the data that is to be read or written from the memory or input-output device. The address bus contains the location of the memory at which location the read or write operation can be performed. The control lines or control bus indicates what operation to be performed. Either it is a read or write. So the system bus is combination of data bus, address bus and the control bus. What is synchronous bus? So each data item is transferred over a time slice. So here two devices that can be involved in the transfer of data. Those units are generally referred as source and destination unit. So these between source and destination unit, the data can be transferred over a time slice. So when during this transfer, the common clock of source or separate clock and synchronization signals are transmitted periodically to synchronize the clocks in the system. So if the processor registers and the source and destination can use or share the common clock, then that can be referred as the synchronous bus. Next variety of bus is the asynchronous bus. So each data item is transferred by handshake mechanism. So here two separate control lines are established in the asynchronous bus. One is the stroke control, second one is handshaking. So in the handshaking mechanism, unit that transmits the data transmit the control signal that indicates the presence of data. So the data validity can be indicated with the control signal that data can be available. So unit that receives the data respond with other control signal to acknowledge the receipt of the data. So data acceptance signal can be raised by the destination unit that it is ready to receive the data in means of handshaking. So in the handshaking control mechanism, so acknowledgement of recipient of data can be raised by the destination unit. So in the asynchronous bus, the source unit and the destination unit can share different clock signals. So thereby two additional control signals can be used for controlling and monitoring of data. They are the handshaking signal and the stroke pulse. So in the handshaking mechanism, there is an acknowledgement so that that guarantees the recipient of the data. In case of stroke pulse, supplied by one of the unit to indicate to other unit when data transfer has to occur. So it can be source initiated stroke or the destination initiated stroke, which unit need to initiate the data transfer can raise the stroke pulse. So in the asynchronous bus, the data transfer can be taken place with the help of either stroke or handshaking. What are the design issue of interprocessor arbitration? So this is the arbitration is the process by which that can establish a communication path between the processor and the memory at a single point of time. So what is the design issues during the processor arbitration? So multiprocessor arbitration schemes usually consider these issues. The first one is the processor priority. So highest priority processor should be served first, and uh, lowest priority processor has to wait. And the second design issue that can be considered is the fairness. So even the lowest priority processor should never be completely locked out from the bus. So if highest priority is continue executing the task, the lowest priority task can be continuously in the wait state. So which cannot be done, so that the priority can be preempted with the help of the fairness, so that the lowest priority task can also be considered after completion of the highest priority task. So what are the types of the interprocessor arbitration? So here three types of interprocessor arbitrations are available. One is serial or daisy chain arbitration. Second one is parallel arbitration. Third one is dynamic arbitration. What is the serial arbitration? So in this type of arbitration, processors can access bus based on the priority. So depending upon the priority assigned to the processor, the processor can has to access the memory or the bus. In serial arbitration, bus access priority resolving based on serial connection of the processor. So depending upon the serial connection of the processor, the arbitration mechanism can be activated in the serial arbitration. The processors connected to the system bus are assigned priority according to their position along the priority control line. So each processor can assign a priority. How this priority can be assigned means depending upon the processor position along the priority control line in case of serial arbitration. So depending upon this priority, the serial connection of processors can be used to access the bus. So in the mode of data transfer, in case of input-output devices, three types of data transfer modes are available: program-initiated I/O, interrupt-initiated I/O, and DMA. So the second category, interrupt-initiated I/O, can be used in this type of processor arbitration. So daisy chain priority interrupt can be used to assign the interrupts. So this is the daisy chain arbitration. So here depending upon the processor position on the priority control line, each processor has to be assigned the priority. So this is the highest priority, next level processor, next level, and the lowest priority. So predefined priority can be assigned for the processor. And here whenever a processor is sharing the common bus line, then it has to keep that bus busy line, and it can be keep in the high impedance state, so that it has to move a 0 to the next processors that it is using the bus. So when multiple devices concurrently request the bus, the device with highest priority is granted to access it. So same request can has to be received at the same time, multiple requests. So how the service can be granted means depending upon the priority assigned for that processor. So the highest priority processor can give the bus access and it can share the data. So each processor has its own bus arbiter logic with priority in and priority outlines. So this is the bus arbiter logic, and each processor can have priority in and priority out control lines. The priority out of each arbiter is connected to the priority in of the next lower priority arbiter. So here this priority out is connected to the priority in of lower priority next lower priority processor. The priority in of highest priority unit is maintained at logic value 1 so that it has to gain the access of the bus. The processor whose arbiter has PI 1 and PO 0, that processor access the system bus. So that processor is having the highest priority, so it can use the bus. What are the advantages and disadvantages of this daisy chain arbitration? So it is a simple and cheaper method. Least number of lines are required. But what are disadvantages means higher delay. High priority processors can share the bus, so that low priority process can be waited. Priority of the processor is fixed depending upon the connection serial number along the connection of the priority control line, and it is not reliable. The second one is parallel arbitration. So in this each bus arbiter in parallel scheme has a bus request output line and a bus acknowledge input line. So here two special signals can be used, that is bus request and bus acknowledge. So the arbiter logic can has to be issued whenever it requires the service of the bus request. So when processor want to access the system bus, at that time arbiter of that processor enables the request line, so which indicates the it requires the service. The processor takes the control of the bus if it acknowledges the input line is enabled. So that after using it, it has to set the acknowledge to the input line so that it can be enabled. So this is the parallel arbitration mechanism. So bus arbiter here for each processor can have two control lines. One is the request, second one is the acknowledge. So which bus requires the which processor requires the bus has to put the request to the priority encoder, so that depending upon the priority, the access can be given to the processor. As soon as access is given, the acknowledgement can be sent to the processor so that the input line of that particular processor can be enabled. So in this way, the parallel arbitration mechanism can work. So the output of the encoder generates a 2-bit code which represents the highest priority unit among those requesting the buses. So depending upon the encoder value, the priority of the processor can be defined. So 2-bit code from encoder output drives a 2x4 decoder which enables the proper acknowledge line to grant bus access to the highest priority unit. So here by using priority encoder, the priority for the processor can be defined and the granting of the bus to that highest priority processor can be done with the help of 2x4 decoder. It works on priority encoder truth table. What are the advantages and disadvantages? So here it requires the separate pair of bus request and bus grant signals. So it is the faster one and requires more bus request and grant signals whenever required the services. So this is the disadvantages of the parallel arbitration. The next type of arbitration is dynamic priority arbitration. A dynamic priority algorithm gives the system the capacity of changing the priority of the devices while the system is in operation. So both the methods whatever we discussed, The daisy chain arbitration and parallel arbitration are static arbitration mechanisms. That means the priority can be fixed. And here in case of dynamic arbitration, with the help of dynamic priority algorithms, the priority of the processor can be changed while the system is in operation. That's why this is the dynamic priority arbitration. So here, what are the dynamic priority algorithms that can be used are the time slice, polling, LRU, FIFO. So these are the 4 dynamic priority arbitration algorithms. What is time slice? So what is the advantages of this dynamic priority arbitration? So the priority can be changed by altering the sequence stored in the control. So the priority can be altered during the system is in operation. So it is more reliable so that the lowest task can also get its fair turn to execute its tasks. So fairness design issue is also satisfied with the help of dynamic arbitration algorithms. So the algorithms that can be used are the time slice. So here in this algorithm allocates a fixed length of time slice of bus time that is offered to each processor in sequentially manner in round robin fashion. So if at all multiple processors are there, they can request a fixed time quantum can be allotted for each processor depending upon the round robin fashion. So the service provided to each processor with this scheme is independent of its location along the bus. In the daisy chain, the priority can be fixed depending upon the location of the processor along the priority control line. But here, independent of the location of the processor along the bus. So the priority can be set depending upon the time quantum and in a round robin fashion. So no preference is given to any particular device since each is allotted same amount of time to communicate with the bus. So the two design issues of the fairness and the priority can also be satisfied with the time slice dynamic arbitration allocation mechanism. Next is polling. So it is also the method of dynamic arbitration. So in a bus system that uses polling, the bus grant signal is replaced by a set of lines called poll lines. So which are connected to all units. So poll lines are used by the bus controller to define the address of each device connected to the bus. The bus controller arrange address in a sequence through prescribed manner. So here each processor can have instead of bus grant signal set of poll lines. These poll lines can be connected to all the devices that are connected with the bus. So that depending upon the arrangement of these poll lines and the requested made by the processor, the address in a sequence through predefined manner can be used to elect the processor in case of polling algorithm. So when a processor that recognizes its address, it activates the bus busy line and then access the bus. So depending upon the address that is generated on the poll lines, that particular processor can be activated for the usage of bus. After number of bus cycles, the polling process continues by choosing different processor. So some cycles, bus cycles can be allotted for that processor. Next address can be generated with the help of the poll lines. The polling sequence is normally the programmable, and as a result, the selection of priority can be randomly done under the program control. So software generated random selection of priority of the processor can be used in the polling arbitration mechanism. Next method is LRU. LRU full form is least recently used. So this algorithm gives the priority to the requesting device that has not used the bus for longest interval. So the processor which is not used the bus for long interval of time, that processor can be given by the highest priority. The priorities are adjusted after number of bus cycles according to LRU algorithm. Okay. So with this procedure, no processor is favored over the other, since the priorities are dynamically changed to give every device that an opportunity to access the bus. So fairness is guaranteed with the LRU, so that lowest priority processor can have its turn to use the bus. The last algorithm is the FIFO. So this is the first come first out. So it requests the processor which requests the first can be ordered can give the service first. To implement this algorithm, the bus controller establishes a queue. So in this queue data structure, the request from the processor can be stored, so that the first request that is raised by the processor can be serviced with the help of the bus with the bus controller. So the queue arranged according to the time that the bus request can be arrived. Each processor must wait for its turn to use the bus on a first in first out basis. So these are the 4 dynamic arbitration algorithms. So in this video, I discussed regarding what is multiprocessor, how interconnection structures can be used in the multiprocessor, how arbitration can be used to select a communication path between the processor and the main memory, what are the types of the arbitration like daisy chain arbitration, parallel arbitration, the static methods of arbitration, and dynamic methods of arbitration with dynamic algorithms like polling, LRU, FIFO. With these, how the time slice, how the dynamic arbitration of processes can be implemented. And the references used in this video are the Morris Meno Computer System Architecture textbook, William Starling's Computer Organization and Architecture, and a web reference. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.